In this illustration, we'll discuss about acceleration of chain on a sphere. Here we are given that a chain AB of length L is placed on a smooth spherical surface of radius R with one of its ends attached to a fixed point P by a thread. We are going to find the acceleration of chain when the thread is burned. Here we can see when we burn the thread, this is the situation. Here is the chain which is placed on this sphere, which is AB, and say the chain is subtending a total angle phi on the center of this sphere, which is point O, and phi we can write as L by R because R is the radius of the sphere and L is the length of chain. When the thread is burned, it will start sliding tangentially to the surface of a sphere. To find out its acceleration, we find out the total tangential force acting on it, for which we consider an element of angular width d theta on this chain and say this element is having a mass dm. Then we can say the mass of element is, this will be dm, which can be written as m by L multiplied by r d theta. If the chain is having a mass m and its total length is L, then mass per unit length is m by L, and the width of this element can be written as r d theta. Now this element would be experiencing its weight dmg in downward direction. As this angle is theta, it will experience a tangential force, that is dmg sine theta, due to which all these elements will start sliding along the surface of a sphere. So here we can first calculate the tangential force on element is, this we can write as df, which is dmg sine theta. And if we calculate the total tangential force on chain, then this force can be written as integration of df, which is integration of dmg sine theta, where dm we can write as m by L r and g sine theta d theta, and it will be integrated within limits from point A to B, where the value of theta will vary from 0 to 5, which is L by r. So total tangential force acting on the chain can be given as mgr by L, and integration of sine theta will be minus cos theta, and we put the limits from 0 to L by r. So this total tangential force will be given as mgr by L. On substituting limits, it will be 1 minus cos of L by r. So in this situation, we can directly calculate the tangential acceleration of a chain, which is given as A tangential is total tangential force upon its mass, which is gr by L, 1 minus cosine of L by r. That will be the final result of this problem.